Hey, Mr. K here. We're going to talk about precision tools today. You have probably seen some of the tools in this picture, especially a stainless steel ruler or a mechanics rule or stainless rule, however you want to call it. But we're going to go through some of these, and I'm sure you've used some of the tools in this presentation, but hopefully I show you a couple new things, a couple tricks. We're going to talk about types of precision tools and examples of usage of each tool. One thing I want to get into your head before you go too far into this, or I guess all the time, is with precision tools, my number one rule is just don't drop them. If you drop them, it can throw off calibration. Things may not read again correctly for the rest of the life of that tool, or you have to send it back to the factory, and then you're out. You can't use that tool for a month or two until the factory gets it back to you. You got a cost involved to recalibrate it. Don't drop them. If you drop them, really what you should do is go to your boss and say, hey, I screwed up. I dropped the torque wrench. We're going to have to send it in, or we're going to have to check it on a torque checker and make sure it's still right. We're going to talk about tools that measure torque, tools that measure distance, tools that measure temperature, and we're just going to have one slide on the precision tool that we're going to use in this class to measure different properties of electricity. Let's talk about tools that measure torque. This is a click style torque wrench. This, by the way, click style torque wrench is what you're going to see most commonly in auto shops. It's probably the most common torque wrench of all. Okay, this is a digital torque wrench, or digital style torque wrench. Now these are really cool. Instead of clicking when you get to the right torque, you set the number of torque that you want, and when you get to the correct torque, they beep at you and they buzz like a cell phone on vibrate, and they're really neat. And a lot of guys I worked with at Chrysler had these, and they thought they were really cool. And seemed like the batteries were always dead, and they were always asking me for batteries or borrowing my click style because their snap-on torque wrench was dead. So, not in my opinion the best thing to have. They're really cool, and I guess if you torque stuff all day and that's your job, probably would speed your job up, but it's another electronic item that can break. Flexible beam torque wrench. You don't see these a whole lot anymore. This is more of an old-timer thing. This would have been something that, you know, my grandparents, your great-grandparents would have probably used, okay, if they're working on something. It works, by the way, they still work, but they're slow. They don't ratchet. It's just a slow process of torquing. And a dial type torque wrench. I saw a lot of these in aircraft shops. I was told that they are more accurate than click style, and that's why we use them. So for what it's worth, I'm not a huge fan of them. Otherwise, they're also kind of slow, but they're supposedly super accurate. Dial type torque wrench. All right, measuring distance. What is this? Hopefully you answered a dial caliper. If that's a dial caliper, hopefully you can kind of use the same logic to say this is a digital caliper. This is what a lot of people mix the names up on. Those are calipers. This is a micrometer. Micrometers are typically the most accurate. They can measure down to the 10,000th of an inch. These typically only go down to the 1,000th of an inch. Just for quick reference, the human hair is 3/1000ths of an inch thick, approximately. All right, so when you're talking to 10,000th of an inch, that's really small. Okay, at this point, go ahead and pause this video and watch this. Quick tip, how to measure and read a dial caliper. Okay, you should have just watched that video on how to use a dial caliper. Micrometers. Let's talk a little bit about micrometers. There's a lot of confusion surrounding these. One of the common things that I hear is people say, well, I would use a micrometer, but because I know it's more accurate, but the part I'm measuring is bigger than an inch, and micrometers only go up to an inch. That's not true. Okay. You can get micrometers as big as you want if you pay enough money. And a good machine shop is going to have a set like this of about 6 micrometers. This does 0 to 1 inch measurements. This does 1 inch to 2 inch measurements. Doesn't do any smaller than that. This would do 2 inch to 3 inch measurements, okay, and so on. Obviously, there's a huge one here. At this point, go ahead and pause this video and watch this video. Using and measuring with an outside micrometer, how to read an inch micrometer. Okay, you should have just watched that video. You might be a little overwhelmed right now, and that's okay. That is a lot to throw at you at once on how to read a micrometer. I don't expect you to know how to read a micrometer after watching that video or even after this presentation. Okay, we'll get there. We will experiment with it, let you have a go at it, but they're tough. I used them all through college, and now if I get one out, I still have to stare at it for a couple minutes to really make sure I remember how to use it. So they're tough. But they are the most accurate measurement device for distance that we have here. Okay, these are so accurate that temperature will affect what they measure. So if you have one of these it's in a 40 or 30 degree garage and you go out there and you work and you measure engine parts, that's going to read differently than if you use this part in a 100 degree garage in the middle of summer, because they're that sensitive. When metal heats up, it expands and it grows. When metal cools off, it contracts or shrinks. All right, another way to measure distance, feeler gauges or thickness gauges. These are stainless steel, okay? These are used if you want to measure a small gap in something, let's say a spark plug, and you cannot fit the jaws of a caliper in that hole or in that space. So you can use feeler gauges. Notice these are stainless steel and they stamped with the thickness of them. So what you can do is you can just stack them up until they don't fit in the hole or don't fit in the gap, and then you know that you've reached approximately the measurement of that gap. Now, some of these will be brass. Sometimes you'll see a set of feeler gauges made of brass, and you might say, why on earth would you need brass feeler gauges? A couple reasons. Some areas, some industries that work around flammable materials or gases all the time. I'll give you an example, NIPSCO that runs natural gas. They sell natural gas up north, especially. Some of their workers that work around natural gas lines are required to use brass everything, brass hammers, brass pipe wrenches, brass feeler gauges, because they don't set off sparks. So if you take brass and hit it, you can hit a piece of brass as hard as you can against a piece of steel pipe, and it will not spark. But if you hit a piece of stainless steel against that, there's a chance you could get a spark and you could blow yourself up. Another reason is if you're measuring the gap in something that's aluminum is a soft metal, and you can mar up the aluminum and chew it up if you're trying to jam stainless steel into the gap. But if you use brass is a soft metal, it won't mar up your workpiece or your aluminum. How about these? I've yet to have someone in class that knows what these are or knows what they're called. These are called pin gauges. These are for when you want to measure the inside diameter of a hole, but once again, that caliper jaws won't fit in the hole. You can use pin gauges. Pin gauges come in all different sizes, obviously, and these would be good, for example, if you want to measure a really tiny hole, let's say the diameter of a carburetor fuel jet. Okay, you can get a set of pin gauges and you can put a pin gauge through it and figure out how large the hole is. Hopefully you're thinking dial indicator. Okay, these can be used in a lot of different areas, but I want you to go ahead and pause my video and watch this video at this time, and you'll just get an idea of one way they're used. Okay, you should have just watched that video. Let's move on. Let's talk about precision tools to measure temperature. Okay, this is a temperature gun. Looks like a gun, right? It's got a trigger. Here is a thermocouple or temperature probe. You see these a lot in high performance. You see them in airplanes. You see them in racing. They use these most commonly to measure exhaust gas temperature. so you don't melt down an engine when you're really running it hard and racing or towing. Another time that a temperature gun is great. Now, this is not a temperature gun. This is just a plain old thermometer. But temperature gun is great for pointing at these vents when you're doing an air conditioning test. So sometimes you can find in a shop manual for a vehicle on a night, it'll say something like on a 90-degree day with the engine running for 10 minutes and the air conditioning on full blast, it should be outputting 46-degree air or 40 to 45-degree F air. So if you know that, you can take your temperature gun and you can point it at this and you should be reading about 45 or 40 degrees F. This is also super useful. I've done this many times. Okay, you've got a engine that's running rough and you think it might be one of the cylinders that's not firing right. You go to the exhaust stacks or the exhaust headers, take your temperature gun, shoot them all. You're going to get maybe 500 to 700 degrees. One of them might read 300. Okay, that's the one that's causing you problems. That's what's causing your engine to run rough. It doesn't have as efficient of combustion. So neat way to use a temperature gun. Electrical. Okay. This is just being used as a voltmeter. Okay, we're going to get into this more later in the electrical unit. This is just to show you. This is an amp clamp or an ammeter that they're using right now. And they're using the multimeter in resistance mode to measure resistors. Okay, so all you really need to know about that is that there's just different ways that that electrical multimeters are used, and that is considered a precision tool, so don't drop it. Okay, at this point, go ahead and complete your assignment on precision tools. Thank you and have a good day.